1 over 2 raised to power 2, then 1 over 2 raised to power x. Yes, if you are just watching this one, this is a continuation of the former video we made on reaction kinetics. This is the exact point we stopped. This is the celebrated Achievers mentorship program champ. We are bringing academic dreams to reality. So let's move on now. So x is equals to what? X is equals to 2. X is equals to 2. So if x is equals to 2, then just put it here. R is equals to what? K E raised to power what? 2. Now, you aren't given three cases, so there's no way you are going to get that of B. But if you check this question well, yes, you should be able to determine that of B. Now, see what I want to show you now. Concentration of B is 0.001 here. Concentration of B is what? 0.001 here. Which type of reaction does not depend on concentration change? That's a zero order reaction. So that tells you that B is what? Raised to power 0. Because this concentration is not what? Is not changing. The concentration is not changing. So that is to tell you that it's a zero order reaction. Let's take one more type of question, then we check our remix. If you have any question on that. Yes. So we have a question here. Yes, I just got this from a textbook. Yes, so they said we should determine the complete rate law of this reaction. Yes, this is it. Let's move now. They said N2O5, so you have R is equals to K into bracket N2O5, right? Yes, so this is N2O5. Then you have to give you what? N2O4. Now, this is what you have to do. They said the following were the data obtained. They said determine the complete rate law. So we don't know the exponent yet, x. So just use for formula, pick any two that you like. Pick any two that you like. So let me pick 1 and 2. What's my rate? 4.02 times 10 raised to power minus 5 is equals to K. What's the concentration of N2O5? 2.4 times 10 raised to power minus 3 over, you can, yes, experiment 2 now. 7, what's my rate? 1.21. 1.21 times 10 raised to power what? Minus 4. Then K, what's my N2O5 for experiment 2? 7.2 times 10 raised to power minus 3. Yes, let's solve it now. So we have this is raised to power x, raised to power x. So yeah, if you press this one in your calculator, you get what? 1 over 3. I solved it without using calculator. I was able to do that. You know that this is the same thing as what? 4.02 times 10 raised to power minus 5. This one is actually also the same thing as what? 12.1 times 10 raised to power what? Minus 5. This and this one, they are the same. Because this 10 raised to power minus 4 has changed to 10 raised to power minus 5. So my decimal shifted. Please, if you don't understand, you just press it in your calculator. Don't let me confuse your confusion. So 4 here is 1. 4 and 12 is what? 3. So that's how I got 1 over 3 without calculator. Is equals to K cancel K. 2.4 over 7.2. That's what? 1 over 3. 10 raised to power minus 3 cancel out. So raised to power x. So 1 over 3 is equals to 1 over 3 raised to power x. X is equals to what? 1. So R is equals to K N2O5 raised to power 1. So this is the first order reaction. Yes, let's check the series and see if they've ever asked the question on this. So yes, let me just check my remix. That's all about the calculation on reaction kinetics actually. Yes, let's move on. So okay, this is the only question they asked on it. This is the only question they asked on it. Yes, they said initial concentration of NO in moles. Let's solve this question together now. They gave you initial concentration of NO 0.001, then final one is what? 0.002. The initial rate 3 times 10 raised to power minus 5. Final rate is what? 1.2 times 10 raised to power minus 4. It should be here. Yes, the maybe the typist or anything failed to do that very well. So yes, let's move on now. What's the formula? R is equals to K. We are dealing with NO. So yes, let's move on now. So we have KNOX, right? So what's your rate? The first one is what? 3.0 times 10 raised to power minus 5 is equals to K. What's your initial concentration? That's what? 0.001 raised to power X. What's the next one? 1.2 times 10 raised to power minus 4 is equals to K 0.002 raised to power X. So let's move on now. So we have just divide. So this will give you what? This will give you 1 over 4. K will cancel K. 1 over 2 raised to power X. So 1 over 2 raised to power 2 is equals to 1 over 2 raised to power X. X is what? X is 2. So R is equals to K NO raised to power 2. So this is the second order reaction. This is second order reaction. So that's just that. So they are now asking you, it can be concluded that doubling the initial concentration of NO, we are doubling it. So in a second order reaction, if you double the initial concentration, it will be what? 2 raised to power 2. That's what? 4. So it will increase the rate by what? By a factor of 4. By a factor of 4. So that's just about that. If you don't get, please, you can just play back. But let me explain the last thing I said. You've gotten now, we got R is equals to KNO raised to power 2. You now said, if we double the initial concentration of NO, yes, the rate will increase by a factor of what? We are doubling this one, doubling it. Yes, that means 2 raised to power what? 2. So the rate will increase by what? Factor of 4. Yes, that's what you said in the beginning. Okay, let me use the second shortcut I gave you. I said, so we don't know. It's just the normal method. Like this is what I said now. 2 raised to power 2. Yes, just is that 2 raised to power 2 is what? 4. 2 raised to power 2 is 4. It's just as simple as that. Just as simple as that. That's the only jump question they asked on this. Yes, let me just quickly make a summary of everything about the theoretical aspect of reaction kinetics now, so that we can be able to solve every question on it. Yes, let's move on now. So yes, let me quickly make a summary of everything in reaction rate. Yes, so we have reaction rate is how fast, a measure of how fast a reaction is. We have different types of reaction. We have a slow reaction and we have what? A fast reaction. Slow reaction is like crusting. Yes, then fast reaction like what? Like neutralization reaction and all of that. This also can, like the oxidation of diamond, everything that slow reactions. And reaction is actually divided into 2 parts. We have reaction kinetics and reaction mechanism. Reaction kinetics is how fast the reaction is, like the rate of the reaction. Reaction rate, how fast, and the reaction mechanism. The steps involved. Yes. So let me just move on now. Let me just talk on how to measure the change in concentration with time for a chemical reaction. Now this is it. If you have a reaction like this, maybe you have KClO3 to give you what? KCl plus what? Plus oxygen. Now in this reaction, now let me ask you, will KClO3 be increasing or decreasing this concentration this time? With KClO3 is your what? Is your reactant. Will it be increasing or decreasing? Now reactants does what? The concentration of reactants decreases with time. At the beginning, they will be what? Very fast. There will be many. Yes, the concentration will be high, but as the reaction is progressing, it will be what? It will be decreasing. So this will be the graph for the concentration of reactants. But for products like oxygen, for instance, we have oxygen. So this concentration, oxygen will be what? Increasing. So the concentration of products increases with time. At the beginning, oxygen will be forming, then it will be increasing. This is the yes. So at this point, this is where we call the end point of the reaction, when either the reactants or the products are used up. Yes. And another thing to note is that the reaction rate is not always constant. It's always fastest at the beginning. Rate is fastest at the beginning. At the beginning of the reaction, it's fastest at the beginning. Yes. While it's what? It decreases. So in a rate curve, the rate curve is what? Steepest. Is the curvest at the beginning. Yeah. So please take note of that. Yes, what other things do I need to talk on? Factors affecting rate of reaction. So I just summarize everything now. We have the what? We have the nature. Of reactants. Another nature, we have what? We have surface area. Yes, let me just talk on surface area now. Then we have bond type. Then we also have what? We have state of matter. So yes, let me start with the last one, state of matter. Which one will be fastest, solid, liquid, or gas? That's what? Gas. Reaction is fastest in what? In gases. Then the bond type, reaction is faster in ionic compounds than in what? Than in covalent compounds. It's faster. Then for surface area, now if you have a block, then you have pellets, then you have powder. Which one will be fast? Reaction will be fastest in what? Powder. What's the reason? Because a large part of that powder is exposed. So a large surface area of the powder form is what is exposed. So this one have what large surface area. So powder will conduct more. Like this block, for instance, there are some part of this block that will not easily be exposed. There are some, like the inner parts, they will not be what, they will not be exposed. But the powder, every form of the powder is exposed. So powder has a what large surface area, So powder will react more than what, than a block or a pellet, because of a what, a larger surface area. Yes, let me explain concentration now. Yes, how does concentration affect the rate of reaction? Yes, it's just a direct relationship. If the concentration is very high, the temperature will be the rate of reaction will also be what, very high. Another thing, yes, this is actually the mnemonic I'm following. NASCO score. This is the factors affecting the rate of reaction. Na for what? Nature, surface area, concentration. Then the next one is what? Temperature. Then we have catalyst and light. So yes, let me take temperature now. Now, temperature increases the rate of reaction. What's the form? Yes, temperature increases the rate of reaction because, you know, like as the concentration increases, as the temperature increases, there will be what? The effective collisions will be what? Will increase. Effective collision will increase. Then the average kinetic energy will increase. And also the particles that have the activation energy will also what, will increase, because the average kinetic energy is increasing. So once the temperature is increasing, they will have the propensity to do what? To react to themselves faster. To react faster. So yes, there's a common jam question on this. For every 10 degree rise in temperature, reaction rate doubles. So let's say your temperature rises by what, 50 degrees Celsius. That will be what, 2 raised to power 5. So the rate will increase by how many fold? 32 folds. Let's say the temperature was increased from 10 degrees Celsius to 60 degrees Celsius, or let's say to 70 degrees Celsius. The reaction rate will increase by what? 10 to 70. That's what, 70 minus 10, that's 60 degrees Celsius. 2 raised to power what? 2 raised to power 6. That's what, 64 folds. So please take care of that. Then we have what? We have catalyst. What is the function of the catalyst? Catalyst what? Lowers the activation energy. Yes, let me draw something like this. You know, we have these are an example of, okay, I hope you know how to distinguish between an endothermic reaction and an exothermic reaction. In an endothermic reaction, the reactant is always what? Higher. This is an exothermic reaction. The energy content, the heat content of the reactant will be what? Will be greater than that of the product. This is the product, this is the reactant. So this one is 40 and this one is 10. So it will be what? 10 minus 40, that's what? Minus 30. So this is an exothermic reaction. The reactant is usually greater than the product. But for an endothermic reaction, the product is usually what? Is usually greater than the reactant. So this is an endothermic reaction now. The product is usually what? Greater than the reactant. Do you get it now? Yes. And they can ask you which one has an higher activation energy. Is it an endothermic reaction or an exothermic reaction? This is the activation energy from here to here. The energy required for reactants particles. This is the energy they must reach for the reaction to take place. This point we call it the what? Activated complex. I'm sorry, just a form of revision. This is the activation energy for an endothermic reaction. So the activation energy of an endothermic reaction is usually greater than the activation energy of a what? Exothermic reaction. Yes. So you can just know it this way. You know, for an endothermic reaction to occur, it must absorb a lot of heat. So the activation energy is usually what? Very high. But what's the function of a catalyst? Catalyst helps to what? Lower the activation energy. So if you have something like this before, and the activation energy before is what? 70. So we can have a catalyzed reaction. They used to do it with dotted line. This is a catalyzed reaction. The first one is an uncatalyzed reaction. So it will be what? It will be lower. So it can be what? It can be reduced to maybe 40 or 50 or anything. So an uncatalyzed reaction will have an higher activation energy than what? Like a catalyzed reaction. The function of a catalyst is to what? Lower the activation energy. So yes, that's all about the theoretical aspect. Okay, finally, light. The reaction that involves light is called what? Photochemical reactions. Yes, that's photochemical reactions. What's the meaning of photochemical reactions? Reaction that depends on light, yes, that requires light to for them to function. Yes. So let's go now. What are the common examples of photochemical? What are the common examples of those reactions? We have the one we have in photography, Ag plus, where we have metallic silver. This is a jam question. It's always asked Ag plus electron to give us what? Ag plus electron. Then we have the what? Chlorination of alkanes. Then you have another one. These are examples of photochemical reactions. You have another one, the reaction of hydrogen and chlorine to give us what? To give us what? To give us HCl. So this is very fast in what? In the presence of sunlight, but it is slow in what? It is slow in diffused light. It's very slow in diffused light. Now, light is a form of a catalyst. It's a form of a catalyst because it contains particles called what? Photons. So we can call light is a what? Light is a photocatalyst. The photocatalyst. Yes, let me just give the common types of catalysts that we have, so I will be able to revise everything with that. Yes, the common catalyst that we have what? We have the catalyst used in Haber process. That's what? Finely divided iron catalyst. Then we have which other one? Catalyst used in contact process. What's the catalyst used in contact process? Vanadium 5 oxide. Yes, catalyst used in esterification reaction. That's what? H2SO4. Which other reaction do we have? Catalyst used in Sabatia reaction. Sabatia reaction. What's Sabatia reaction? The hardening of oil. The hardening of oil. Catalytic hydrogenation of oil. To give us what? To give us margarine. What's the catalyst used? We use nickel or palladium or platinum catalyst. Which other common reaction do we have? What's the catalyst used in the decomposition of oxygen? Oxygen is we use what? Manganese 4 oxide. Then we have the catalyst that we use in the conversion of starch to maltose. This was SDM, diastase. SDM. Yes, the catalyst that we use in the conversion of maltose to glucose. That's what? Maltase. Then the catalyst that we use in the conversion of glucose to ethanol. That's what? Zymase. And this zymase is from what? Yeast. So that's just that about everything they can ask. Let me just review the past question, everything from the beginning to the end. Yeah, question 1. Okay, they said the graph demonstrates. Okay, the graph was not given. Yes, let's move on. Which of the following will increase the rate of reaction? You should know that that is increase in temperature, addition of catalyst, then what? Increase in the surface area. That will increase the rate of reaction. Yes, which one? The rate will be greatly increased if the zinc is what? Is in powdered form. I already established it. Number 4, even without checking anything, you know that I say this. Option A, for a 10-degree rise in temperature, the rate of reaction is what? Doubled. Yes, if I'm too fast when I'm doing the summary, you can just check out our audio summary of reaction kinetics. The summary of the theoretical part is there. I intentionally rushed because this video is actually meant for calculations alone, so you can go through the questions. Yes, question 6 is a question on surface area. Question 7, what's the function of catalyst? Lowers activation energy. We've treated question 8 before. Yes, is a calculation. Question 9, they said which curve will produce y. Which curve? I gave this reaction exactly in class. X is a what? A uncatalyzed reaction. Then I said dotted line is for what? We've added catalyst. So they said which of the following will produce curve y, addition of a catalyst. So it's as simple as that. We've done 10 before, we've done 11, we've done 12. Yes, powdered marble. Yes, why do powdered marble react faster than granular marble? Because they have what? A larger surface area. We've done number 14 before. Yes, why do we have increase in rate of reaction as the temperature increases? Yes, I said that because of what? Because yes, an increase in what? Collision frequency. This is I said it when I was doing the revision. Okay, yes, this next question, Arrhenius equation, is actually in the summary, the audio summary. Arrhenius equation shows the relationship between what? Between the activation energy and what? And the speed or the temperature of the reaction. It's actually a relationship between the activation energy and the what? And the temperature. But you know that temperature relates with the speed. That's why they use the speed here. So you can use it this way: activation energy A, Arrhenius equation. Arrhenius equation. Yes, Arrhenius equation is actually Arrhenius equation AE raised to power what minus R over T. Yes, something like this. Yes. So no, I think activation energy over T. So this is the temperature. Yes. Okay, which of the following curve will represent the production of CO2? They didn't draw the curve actually, but remember I gave you CO2 is the what product? Is the product. So the curve will just be something like this. It will be what? It will be increasing. It will be increasing. Yes. Next question. Which of the following will change when a catalyst is added? Catalyst changes what? The activation energy. The efficiency of a solid catalyst to increase the rate depends on its what? Surface area. When you increase the surface area, it will be what? It will be very fast. Number 20. Which of the following represent a photochemical reaction? You know I told you conversion of silver light to what? Grey metallic silver. I gave you the equation Ag plus electron to give us what? Ag. Never forget. Which of the following will introduce the greatest increase in the rate of reaction? Decrease in temperature? No. Increase in temperature? Yes. Decrease in concentration? No. I said the concentration must increase. The temperature must increase. Then the surface area must be large. So this is it. Increase in temperature and increase in concentration. Next one. A catalyst speeds up the rate of chemical reaction by what? Lowering the activation energy. Yes. Which of the following will represent the evolution of oxygen? Oxygen is a what? Is a product. So how will it be? It will be increasing. So which one represents it? R. This is R, increasing. This. So the answer is R. The answer is R. Next question. A catalyst increase the rate of chemical reaction by providing a path that was lowers activation energy. Can you see? Yes. In the preparation of oxygen by heating KClO3 in the presence of manganese oxide, only moderate heat is needed because the catalyst acts by what? Lowering the activation energy. So it lowers the activation energy is like the energy barrier too. Yes. Can you see this one now? You have a normal marble. When you use normal marble, the reaction takes T2. The reaction occurs after a time. But when you use powdered marble, the reaction is done at this time. So that shows that the time for marble chips is what? Is greater than the time for what? Powdered marble. That shows that what? Powdered marble is what? Powdered marble reacts faster than what? Than marble chips. What's the effects? What are they showing here? The effect of surface area. The effect of surface area. So that's option D. What will affect the rate of this reaction? I told you that halogenation of alkanes. This is an alkane. Methane is a photochemical reaction. That's what light. Yes, the diagram above best illustrates the effect of decrease in what? This is concentration. I told you already. KClO3, it will decrease. You understand? The reactant decreases with time. So this is the effect of concentration. Number 30, the highest rate of production of CO2 can be achieved by using what? Yes, so you use a powdered CaCO3, then the concentration must be high. So powdered and what? High concentration, 0.1. 0.1. This is the highest concentration among all the options. This is the highest, then use powdered. Number 31, in a chemical reaction, the change in concentration of reactants with time is the what? Is your rate of reaction. Change the concentration over time. Number 32, in a chemical reaction, when the energy of the colliding reactant particle is less than the activation energy. Now, the energy of the particle is not up to activation energy. The reaction will not occur. It must be what? It must be up to the activation energy. They must reach this threshold. Now I do something like this. Yes, this is the activation energy. So if they did not reach this energy, the reaction will not occur. Yes, the presence in the use of asbestos support to platinum block. Why do we prefer asbestos to block to platinum block? Because of what? Surface area. Yes. What's the reason? Because asbestos must give us an increased surface area. So we are done with all the questions and everything you need to know about reaction kinetics. So thanks for staying through with us. Join us in the next topic. Please drop a comment for us. Then don't forget to share, like and subscribe on this channel.